Alright, good afternoon, y'all. We're going to come back with another video. And before I get started, I want to go back and there's a couple of things on the multiplying and dividing rational expressions I want to look back at. There was a problem that some of you either put a question mark by and didn't do, or you either did it and didn't do it completely right. So this is number 11 on the worksheet if you want to look back at your paper, see if you were one of them or not. So, remember on dividing, that means the first fraction stays the same, and this needs to be factored. That is a trinomial. That's going to be what are factors that make negative 12, make negative 12, but they combine to give you a positive 4. I believe that would be x plus 6 and x minus 2. And then the dividing changes to multiplying, and then I'm going to invert or reciprocate that one, the second one only, and that becomes this. Now, some of you kept the dividing sign, and then you flip this or didn't flip this. Notice that it becomes a multiplying sign. Then we reduce this, and then several of you left 30 over x plus 6, and then you had 6y. Now, that is okay, but the fact that this is not combined with a plus sign, that means that 6 can actually reduce into the 30, and that final answer really should have been 5 over x plus 6, and then either stick the y in front or in the back. So that's really what your answer should have been. So that's one of the ones I wanted to address. A lot of you didn't do that one quite right. There's one more on that same worksheet. It's number 12, and it goes x squared minus 10x plus 9 over x squared minus 1, and this one's multiplying, so we're not going to change it to multiplying and divide, flip it. We're just going to keep these the same, except we do need to factor all the 4 parts. So on the top here, this is a trinomial. We want factors of 9 that'll combine to give me a negative 10. That would be x minus 9 and x minus 1. On the bottom, x squared minus 1. What is that? Yes, that is the difference of two squares. One's a perfect square. X minus 1, x plus 1. And then over here, x plus 4. It is a binomial, but it's nothing in common, and it's not the difference of two squares. So that technically just stays as one factor there. This is the trinomial, factors of 36, negative 36. That'll give me the negative 5. That would be an x 9 and 4. So that's x minus 9. That'll give me the negative 5. X plus 4. Let's check it. That does give me negative 36. That does combine to give me negative 5. So that is factored. So we're going to mark out our common ones, which is going to be x minus 9, x minus 9, x minus 1, x minus 1, x plus 4s, and x plus 4. Notice the only thing left on the top is nothing. The only thing left on the bottom is this x plus 1. So I had a lot of people put x plus 1. Now, and that is not correct, because when you leave it just like this, that's understood to be over 1. That implies that the x plus 1 was on the top. And you can see there everything on the top marked out. So actually your answer should have not been like that. You should have put the x plus 1 still on the bottom. And on the top, you should have left the 1 for the top, because those reduced. I say they marked them out, but technically they all reduced. And so it became this right here. Several of you left it the opposite way. Just wanted to point that out and show you why it is what it is. Now, the next thing I want to go is a couple of problems on the adding and subtracting that we did. And this is important because we're going to review this week as well as add on to it. Now, there was a problem that was actually number 5. And I'm going to apologize right now for this video being a little longer, but I figured you'd rather do one a little bit longer than two different ones. And so I'm going to try to go as hurriedly as possible. If you got any questions, just ask me, slow me down. I'll try to stop. So when I look at this, remember for adding and subtracting, you have to have a common denominator. So when I look at these, both of them have an x, but the 4 and the 12 are not the same. Most of you knew that 4 can become a 12 by multiplying it by 3. Whatever you put on the bottom, you put it on the top. So that makes this one become 12x. That makes this one become 12x. The top here is going to be 15. That 7 is going to stay because nothing got changed. Your answer is 22 over 12x. Now, I'm going to be honest. When I saw this answer, as I glanced through papers, I was proud because it either meant one of two things. You didn't use an app, or you copied somebody who didn't use an app. And so, so the deal is, this right here has no plus or minus signs, therefore it could be reduced. So 2 goes into both. That should be 11 over 6x. That's really what you had. Now, some of you did get this, and you got it honestly. However, I wasn't born yesterday, but only the day before. So I know that some of you got this by getting an app. I can generally tell who's getting stuff by apps and who's getting stuff on their own. And I've even been able to tell who's getting stuff from other people, because it's amazing how some people get the same wrong answers on the same ones, on the same thing. So now I still love you, and I'll still give you some animal crackers, and I'm not going to call any names or initials, but I know, just know that I know and I recognize things. But hey, I'm like this. At least you're trying, because I got some people out there who are wanting to get a 0 for everything, and so they're gonna not be liking their grade when I change it. So now on this problem right here, this is a binomial, but there is nothing to factor out. There is not the difference of 2 squares, so I brought it down. This right here can be factored. I can get factor out of 4 that's in common. Goes into both, so that's going to give me x minus 6. Now, so when I look at these two problems, remember, I need a common denominator. These need to be the same. They are almost the same, except that one has a 4. So why don't we put a 4 over here with this one, which whatever I put on the bottom, you know I have to put it on the top. So that gives me 4x minus 6 here. On the top, that would give me 4 times 3x is going to be 12x. Plus, that one already has all that junk. So it's going to stay that, and it's going to stay 6x on top. Now that I do have my common denominator, the tops will combine. Both of them are like terms. 12x and 6x used to be 18x. Sometimes still is. And that's going to give me this on the bottom. Now, again, a lot of you left it like this. And to be honest, I was very proud. I knew either one of two things. You either earnestly tried it and you thought you needed to stop there, or you copied somebody who earnestly tried it and thought to stop there. But the deal is, this does not have a plus or minus. So therefore, it's not a unit that has to all be together. I can still take the 4 and the 18 and reduce them. What goes into both of them? Yes, 2. I heard it. So that's going to be 9x. When I divide 18 by 2, divide that 4 by 2, which will give me a 2, and x minus 6 is going to stay. Now, you do have to leave it as that for your final answer. Just one, that was number, let's see, that was number 5 again. No, just kidding. Number 7 from the adding and subtracting worksheet. If you want to look back at it, that should have been your final answer. Okay, now, so as I'm changing over to go to what our real topic is for today, which is going to be solving rational equations. Okay. So we're still got that rational. We still got those fractions going on, and basically it's going to be adding and subtracting, but we're going to put an equals with it because it's equations. Okay, so now I have noticed that several people have done worksheets without ever watching the videos. Now, I'm not saying that some of you aren't smart enough, but unless Coach Cheek's doing a private lesson tutor up there and having a breaking the distance learning thing up there in Sly County, I think a lot of you are just using the app. That's why the videos are required, so that you have to watch it and at least kind of try to figure out what the app people did who gave you the answer. Okay, so now the deal is, which I know if you're watching this, you finally have succumbed to doing that. But that's why I keep harping on these videos. I want you to at least listen. And I know some of you are doing, trying to do a good job with that. But I'm going to teach you how do you add, how do you solve a rational equation. So it's going to be a lot like last week, but we're going to add, it's going to be a little bit more added on to it. Okay, so I have this equation first. So notice if you, so if I take this off, that's about what we did last week. But this week we're adding on to with an equal sign, as I said. The idea, though, is exactly the same. Just like last week we wanted the denominators to be exactly the same, we still want all the denominators to be exactly the same. That's your first thing. So I've got a 4, an x, and a 4, and an x. So therefore, all of them need an x. This one right here doesn't have an x. So I'm going to put it, remember, whatever I put on the bottom, I have to put it on the top. Hold on, I'm going to go back and change that to a different color if I can. And so whatever I put here, I'm going to put it right here. All right. So I got 4x. So now that one and that one actually look the same. But this one still needs the what? A 4. Good, I thought I heard it. So I'm going to put a 4 with it. And then whatever I put on the bottom, I have to put it on the top. That's not 47. That's my age. Not the, what should be up there. All right, so that's 4x, 4x, 4x. Now, the thing you have now that all of them are the same. So your first thing is get all, that spells all, in case you didn't know that. The denominators the same. Then basically at that point, you're going to ignore the denominators and only work with the top. So that means I've got 1 minus 3x equals 4 times 7 is 28. And that is not a decimal point. Don't think of it as. So basically I've got an equation. So basically we're going to do what we did last week, but then it's going to end up converting into an equation to solve. Now, how do you solve an equation? That means we're solving for x. That means I need to get rid of the 1 and I need to get rid of the negative 3. Which one do I move first? I'm going to subtract 1, subtract 1. Move that over. I've got negative 3x. Don't forget to bring down the negative. Equals 28 minus 1 is going to be 27 over here. All right, last step. Divide by what? Negative 3. Very good. And so x is going to be negative 9. That's your answer right there. Well, you could go back and you could put it in and check it in your original answer. Now, technically, if we were in school, I'd probably have to do a lot more of this. With equations, you have to actually make sure, a few videos back, it talked about excluded values, like what would make this be a denominator of 0. And so, basically, what would make 4x equal 0? That's if you divided 4, and so x can't be 0. But our x value was negative 9, so you were good to go. I would harp on this a lot more if we were in class, but if you can get me an x equals a number and focus at least on solving that equation, I think we're going to be good to go for what we're dealing with. All right, anybody got a question? Good. I'm going to recap what I did. Got the denominators the same. Once I got the denominators the same, I ignored the denominators and only worked with the top to solve this equation. All right, let's do another one. All right, anybody got any questions? All right, if you do, email me, write them down so you can email them to me. Here's another one. 7x over x squared minus 2x minus 15 plus 3 over x minus 5. equals 6 over x plus 3. Okay, now, so same thing. Just like last week, you got to get these to be the same. Well, the only difference is now you've got another one that you've got to get them to be the same. So therefore, I'm going to, this can't be factored, this can't be factored, but you realize that one right there is a trinomial. So we're going to have to factor that. Factors of negative 15, which would be 1 and 15, or the 5 and 3, but the 5 and 3 are going to give me that negative 2. So that's an x and an x. I want a negative 2, so that's negative 5 and positive 3. Check yourself. That does give me negative 15. It does give me negative 2 when I combine it. All right. So, oops, forgot that. So now factor that. Now, so I've already said these can't be factored. And so I'm going to bring them down. So I need all of them to be the same. So when you look at it, these are sort of kind of easier in some respect because you're like, oh, these are probably the factors that one's going to be. So what is, let's go to a different color. Let's go to a different color, and yeah, let's do that. Let's see, is that going to work? So I need, yes, all right. So what does this one need to be like this one? It's got the x minus 5. It needs the x plus 3. Whatever you put on the bottom, you got to put it on the top. That's a 3. Now it looks the same as this one. Okay, let's go over to this last one. It's got the x plus 3, but it doesn't have the x minus 5. Good, I thought I heard it. So I'm going to put it wherever you're on the bottom. You got to put it on the top. Now all three denominators look exactly the same. So once you do that, I told you once you get them the same, you basically ignore the denominators and only work with the top, which is going to give me an equation. So I've got 7x plus, and I'm going to write it all down just like it is, even though I know some of you kind of do some shortcuts, but I want to know that's basically all my numerators, sorry. So I need a lot of cleaning up. This is going to be 7x. This is going to distribute to 3x plus 9 equals distribute. It's going to give me 6x minus 30. Clean up the left-hand side. That's going to become 10x plus 9 equals 6x minus 30. Now, for y'all who haven't solved equations in a long time, remember these, the 10x and the 6x need to get together. They're not on the same side. So I'm going to move the 6x, subtract it to get it on the same side. I'm going to bring it over here, y'all. That's going to give me 4x plus 9 equals 30, negative 30, sorry, is what's left. I'm still solving. I'm going to need to get rid of the 4 and the 9. I'm going to subtract 9 first, which is going to give me 4x equals negative 39. Divide by 4. Divide by 4. X equals. 4 will not go in there perfectly. I am fine with the fraction, or I am fine with the decimal, which would be negative 6. No, just kidding. Negative 9.75, I believe. So, that I'm good with either one of those. So recapping, I had to factor. Then I had to get all my denominators the same, ignore the denominators, work with the numerators to solve this equation. Final answer is negative 39 over 4. Again, you would have to consider, is that an excluded value? But if you look at here, what would the excluded value be here? Negative 3. What would it be here? 5. Because that 5 minus 5 would make that 0. And then, of course, here, that would actually be both of those because those are your factors. But for your work, for me, you only have to tell me this. You don't have to tell me about the excluded values. All right? Anybody got any questions? Anybody? One more time. One more time. I know you're looking at the clock. Me too. I'm going to give you one more. And this one looks harder, but it's really like super easy. So that's why you know how sometimes though I always say the ones that are really easy, sometimes y'all think are harder. So Because you're like, well, this one ain't even got no fraction. All right, so the deal is, but you'll notice that here, what's the good news? They're already the same. That's good. So I just need this one. Well, that's like 1 over 1, right? So what do I need? I need this one to be, and by the way, these can't be factored. Just, I looked at them myself and saw it couldn't be. It's not the difference of two squares. There's nothing in common. So there's nothing no factoring to go on, and they're already the same. Basically, I need this one to be x minus 3. So that means I'm going to put an x minus 3 here. And whatever you put on the bottom, you put the same thing on the top. So notice that still would reduce to be the one that we started with, but we don't want to reduce it because then it would defeat the purpose. But so now you've got a common denominator on all of these. We're saying, well, that one's got a 1. Well, just remember, y'all, those technically have a 1 in front of it. It doesn't change it. So don't get all bent out of shape about that. So the main thing is you've got a common denominator of x minus 3. That's your common denominator. So that means once you get your common denominator, ignore the common denominator and just work with the numerator. So that's going to give me 7x plus, if it makes you feel better, you can write that down, but it's not necessary here. So I've got an equation that I got to solve and clean up. That's going to give me 7x. Now, I know this, but some of you don't always recognize that, so I'm going to distribute 1, which is going to give me 1x minus 3. If you're a math teacher watching this, I know, but if you're like me, you have kids who don't always recognize that, so I'm just going to go through the motions. So here I am going to combine those. That gives me 8x minus 3 equals 8. Remember, these were on the same side. That's why I just combined them and didn't subtract them or anything. They were like terms on the same side. Gave me 8x. So I'm going to add 3 at this point. And that's going to give me 8x equals 11. 8, 9, 10, 11. Divide by 8. Divide by 8. And x is going to be 11 over 8. You can give me the decimal if you want to. However, I am super fine with it being just like that. Now, and that is your final answer. So, again, you need, main thing you need to do is, on these, is factor, if necessary, to get a common denominator. Get all denominators the same. That means multiply on top and bottom. And number 3, then you're going to solve the equation of the numerators. So that's about it. Be careful. I know some of y'all are some of y'all are, quote, working together. So be careful, guys. Don't let the girls do all your handwriting for you, because just in case you didn't know, I do recognize when the guys get girls to do their problems for them. I recognize there's a handwriting difference. So I hope all of y'all are doing good. Missing y'all, and this is the only video for this week. So hope you're having a good week. Let me know if you got any questions. Bye.